Hello my dear students, in this lecture we are going to learn triple point concept. Now my dear students, triple point is a point where any substance exists in solid, liquid as well as in vapor state. Here at triple point any substance exists in solid, we can say the same substance exists in solid as well as liquid as well as in vapor state, means it is three phase mixture. At triple point it is a three phase mixture. And my dear students, triple point temperature of water is a reference point for the measurement of temperature. Now for pressure measurement, atmospheric pressure is a reference pressure. Similar to that, triple point temperature of water is a reference temperature for measurement of temperature. Now here let us understand this triple point temperature. Now at triple point of water, we can say the temperature at this triple point is 0.01 degree Celsius, which is nothing but it is 273.16 Kelvin. Now you must know that here 0 degree Celsius is nothing but 273.15 Kelvin. This is the conversion of degree Celsius into Kelvin. Therefore, both sides, if I add 0.01, then it will become 273.16 Kelvin. Right. So, my dear students, from this we can define 1 Kelvin. Therefore, from this, if I divide both sides by 273.16, then we will get 1 Kelvin. Therefore, we can say 1 Kelvin here divide with 273. Triple point temperature divided by 273.16 is equal to 1 Kelvin. Therefore, we can define 1 Kelvin is defined as it is equal to 1 upon 273.16th part of triple point of water. 1 Kelvin is equal to 1 upon 273.16th part of triple point of water. This definition is very much important. From this we are calculating Kelvin temperatures, right? Therefore, many times they have asked this definition directly. 1 Kelvin is nothing but 1 upon 273.16th part of triple point of water. Again, water is important, my dear students, because this triple point of water is a reference point for the measurement of temperature. Now, at triple point, the substance exists in solid, liquid, and vapor state. Therefore, at triple point of water, we can say at triple point of water, the substance that is H2O. Here, chemical formula of water is H2O. This H2O exists in solid, liquid, as well as vapor state. Means this H2O will be in ice form as well as in water form as well as in steam form, that is water vapor form. Therefore, at triple point of water, the water exists in ice as well as water as well as in vapor state. Now my dear students, every substance is having this triple point. Now for water, let us understand this triple point. Therefore make a note, triple point of water, H2O, right? Now for triple point of water, for understanding this concept, we are drawing pressure versus, here we are drawing pressure versus temperature diagram. On y-axis, let us take pressure, and on x-axis, let us take temperature. Now we will draw this triple point on pressure versus temperature diagram, right? Here on x-axis, on y-axis there is a pressure, and on x-axis there is a temperature. Now my dear students, for this triple point is a point where substance exists in solid, liquid as well as vapor phase. For H2O, that is for water, it will be in ice as well as liquid, that is water, as well as in vapor form. Now there will be one line called sublimation line. Here there will be one line called sublimation line. This line is sublimation line. Now we will see the meaning of all these lines. After sublimation line, there will be a vaporization line. Here this line is vaporization line. And there is one more line which is called fusion line. The fusion line for water is like this. Now this line is called fusion line. And my dear students, between fusion line and sublimation line, the phase is solid state. Here between fusion line and sublimation line, the state is a solid state. Between fusion line and vaporization line, the state of substance is liquid state. And my dear students, between sublimation line and between vaporization line, the state of substance is vapor state. The state of substance is vapor state. So my dear students, we will find one point where sublimation line, vaporization line and fusion line meets, right? Now here, therefore, whenever fusion line and sublimation line meet, then we will get here solid state, therefore here there will be a solid. Whenever fusion line and vaporization line meet, then we will get liquid, here liquid. And whenever sublimation line and vaporization line meet, we will get solid vapor, therefore there will be a vapor. Therefore we will get one point where there will be a solid state, liquid state as well as vapor state. This point is called triple point. This point is called triple point, right? And for water, there will be a ice, there will be a water, and there will be a water vapor also. Now for water, this triple point temperature is 273.16 Kelvin and triple point pressure is 610.42 Pascal. Let us write down this. Therefore, for water, the temperature at triple point is nothing but 273.16 Kelvin and pressure at triple point. Pressure at triple point is 610.42 Pascal. These values are important. Generally, they will ask you the temperature at triple point for the water, which is nothing but 273.16 Kelvin. Now, my dear students, here sublimation line. Can you imagine here for sublimation line, as pressure is increasing, simultaneously temperature is also increasing. Means if change in temperature is positive, change in pressure is also positive. Therefore, the slope of sublimation line is positive. That is change in temperature. Temperature is increasing, then pressure is also increasing. Therefore, slope of sublimation line is positive. Similarly, for vaporization line, as pressure is increasing, temperature also increasing. Therefore here for vaporization line also, as temperature increases, x coordinate increases, y coordinate also increases. Therefore slope of vaporization line is also positive. But my dear students, here one thing is that the slope of sublimation line is more than vaporization line. Can you see here? The slope of sublimation line is more than vaporization line. If I extend this sublimation line, the line will go like this, right? Now here, if I extend this sublimation line, the line will go like this, right? Therefore you can see the slope of sublimation line is more than vaporization line on pressure versus temperature diagram. Now for fusion line, here as pressure is decreasing, temperature is increasing. Therefore you can see as the y coordinate is decreasing, means pressure is decreasing, then temperature is increasing. Therefore slope is negative. So my dear students, for water, slope of sublimation line and slope of vaporization line is positive and slope of fusion line is negative. But here slope of sublimation line is more than slope of vaporization line. My dear students, there are only three components having negative slope for fusion line. That is, first is water, second is antimony, and third is bismuth. Only these three components are having negative slope for the fusion line, right? And rest all the components will be having positive slope for the fusion line also, right? Now let us understand the few things about this triple point. My dear students, this triple point looks like a point on pressure versus temperature diagram. Here we have drawn pressure versus temperature diagram. If we draw pressure versus temperature diagram, this triple point looks like a point, right? If we draw here pressure versus volume diagram, means on pressure versus volume diagram, this triple point looks like a line. This triple point looks like a line. And if we draw energy versus volume diagram, therefore for energy versus volume diagram, this triple point looks like a triangle. This triple point looks like a triangle. Now let us understand few important or few very interesting facts as well as important facts regarding this concept of triple point. Now my dear students, whenever any substance heated at a pressure less than triple point pressure, then solid directly becomes vapor. My dear students, what is my statement? Whenever any substance heated at a pressure less than triple point pressure, means somewhere here, right? Then solid directly becomes vapor. Here solid is directly becoming vapor, and the process is called sublimation. Means during phase change, here we are going to write some few phase changes, right? Phase change means the substance changes from one state to the other state. Now whenever solid directly becomes vapor, then this phase change is called sublimation. This phase change is called sublimation. And when this happens, whenever any substance is heated Heating means temperature increases at constant pressure and the pressure is less than triple point pressure. Whenever substance is heated at a pressure less than triple point pressure, then solid directly becomes vapor and the process is called sublimation. And the reverse is called ablimation. Means if any substance is cooled at a pressure less than triple point pressure, then vapor becomes solid. Now here, cooling of any substance at a pressure less than triple point pressure, then vapor becomes solid and the process is called ablimation. Therefore, whenever vapor converts into solid directly, then the process is called ablimation. Now sublimation and ablimation, when these processes we will get, whenever we are operating at a pressure less than triple point pressure, then we will get sublimation and ablimation. And on heating there is a sublimation, that is solid to vapor conversion, and on cooling there is a ablimation, that is vapor to solid conversion. Now next is, if any substance is heated at a pressure more than triple point pressure, let us say now the pressure is somewhere here, let us say the pressure is somewhere here, right? Now if any substance is heated at a pressure more than triple point pressure, then solid will convert into liquid first and then liquid will convert into vapor, right? This will be the order of phase change. Now here, if you understand, whenever conversion of solid into liquid, this is called the conversion of solid into liquid or conversion of liquid into solid. Such type of phase change is called fusion. This is the fusion, right? Conversion of solid into liquid or liquid into solid is called fusion, right? And conversion of liquid into vapor or vapor into liquid is called vaporization, is called vaporization, right? That is, liquid into vapor is vaporization and vapor into liquid is condensation. That is, we can say here simply, let us understand here, liquid into vapor is vaporization and vapor into liquid is called condensation. This phase change is called condensation, right? The meaning is same, vaporization and condensation meaning is same. That is, but in case of vaporization heat is supplied, in case of condensation heat is removed. Now similarly, whenever any substance is heated at a pressure more than triple point pressure, solid becomes liquid first and liquid becomes vapor. Similarly, if any substance is cooled at a pressure more than triple point pressure, then first vapor becomes liquid and then liquid becomes solid, right? This will be the order of phase change, right? Now my dear students, whenever you heat ice, let us say you are heating ice, then what is the order of ice for phase change? Ice becomes water and after heating again water becomes vapor. Means why this is so? We are heating this ice at a pressure equal to 1 atmospheric pressure, right? The heating of ice will be at a pressure equal to 1 atmospheric pressure, right? Because in atmospheric condition we are doing operations on the ice. Therefore 1 atmospheric pressure is nothing but 1.01325 bar, which is nothing but 1.01325 into 10 to the power 5 Newton per meter square. Newton per meter square is nothing but Pascal. Therefore 1 atmospheric pressure is nothing but 1.01325 Pascal. This is the 1 atmospheric pressure. And my dear students, can you say this 1 atmospheric pressure is very much greater than 610.42 Pascal, right? And triple point pressure of ice is, or triple point of pressure of water is 610.42 Pascal. Therefore whenever we are heating ice at a atmospheric condition, means we are doing operations on the ice at a pressure more than atmospheric pressure, that is 1 atmosphere, sorry, at a pressure more than triple point pressure, that is atmospheric pressure. Therefore first on heating ice, first ice becomes water and water becomes vapor. This will be the order of phase change. Now again let us understand few things about this triple point. Now here temperature at this triple point is nothing but 273.16 Kelvin and pressure at this triple point is 16.42 Pascal. Now let us understand compression and expansion processes. Now isothermal means constant temperature. Isothermal means constant temperature, and at constant temperature whenever there is a compression, pressure increases for compression, right? For compression, and pressure decreases for expansion. Pressure decreases for expansion. Now let us understand this isothermal compression and expansion process at various temperatures, right? Now let us say isothermal compression at a temperature more than triple point temperature. Here there is a triple point temperature 273.16 Kelvin. Now if I consider temperature at more than triple point temperature, let us say T1, and isothermal means constant temperature. Compression means pressure increases. Therefore isothermal compression at a temperature more than triple point temperature, then vapor becomes liquid. Again, reverse of this, isothermal expansion at a temperature more than triple point temperature, then liquid becomes vapor. Right. Similarly, isothermal compression, here the isothermal compression at a temperature less than triple point temperature, let us say the temperature is somewhere here T2. T2 is less than triple point temperature, right? Now isothermal compression at a temperature less than triple point temperature, compression means pressure increases, therefore vapor becomes solid. For this case, vapor becomes solid. And isothermal expansion at a temperature less than triple point temperature, then solid becomes vapor. This will be the order of phase change. Now my dear students, this triple point pressure for the carbon dioxide, that is dry ice, solid carbon dioxide is called dry ice, right? For dry ice we will looking for dry ice. Dry ice is nothing but solid carbon dioxide. This is used for refrigeration, in refrigeration subject that we will see, right? Now let us draw pressure versus temperature diagram. Now here, this triple point pressure of dry ice, triple point pressure is 5 atmosphere. For solid carbon dioxide or for dry ice, triple point pressure is 5 atmosphere. Now here there will be a sublimation line. This is a sublimation line. After sublimation there will be a vaporization line. Here this is a vaporization line, right? And there will be a fusion line. And now my dear students, fusion line is like this. Here this line is fusion line. Now my dear students, here the slope of fusion line is positive, because only antimony, bismuth and water is having negative slope for fusion line. Here for fusion line, as temperature is increasing, pressure is also increasing, therefore all will be having positive slope. Here sublimation line, vaporization line and fusion line all will be having positive slope only, right? Between fusion and sublimation line there will be a solid state, between fusion and vaporization line there will be liquid state, between vaporization and sublimation line there will be a vapor state. And my dear students, this triple point pressure for the dry ice is 5 atmosphere. Now whenever this dry ice is kept in atmospheric pressure, that is whenever it is kept in atmospheric condition, that is 1 atmosphere, this dry ice will absorb heat from the atmosphere and directly convert into vapor, that is solid becomes vapor. Solid directly converts into vapor, and the process is called sublimation, right? Therefore my dear students, you will never see the dry ice or carbon dioxide in liquid state at atmospheric condition. What I am saying, you will never see this carbon dioxide in liquid state at atmospheric condition, because at atmospheric condition solid directly converts into vapor because of 5 atmospheric pressure as a triple point pressure for the dry ice. Thank you dear students. In next lecture we will see pure substance and Gibbs phase rule.